Hello everyone and welcome to the Curious Calculator. Today we're going to be going over the following problem. Graph the following rational function. F of x equals x cubed minus 6x squared minus x plus 6 over x squared minus 4. And I'm going to be doing this problem by following the 4 recommended steps listed here. So let's go ahead and get started with the first one. So number one, we want to simplify and identify any holes. All right, so let's go ahead. Let's see, f of x equals, and I'm going to go ahead and try simplifying by factoring the numerator here by using factoring by grouping. And so looking at these first two terms, it looks like I can take out an x squared. So x squared, and that's going to leave me with x minus 6. And the second one, I can take out a negative 1 so that I'm left with an x minus 6. So minus 1, x minus 6. Awesome. And let's go ahead and factor out the denominator here. We can notice that the x squared minus 4 is a difference of two squares. And so that is going to factor, well, I'll write out the pattern here. So if we have a difference of 2 squared, a squared, minus b squared, that equals a plus b times a minus b. And that should be a 2. Okay. And so this one is going to become x plus 2, x minus 2. All right, so let's continue on here, factoring by grouping, and I will make the note here as well that factoring by grouping, really when we go from this step to the next step, what we are using is the distributive property. And so let's see here, that is that a times b plus c equals a times b plus a times c. And so what we are starting with here in the numerator would be something like the right hand side of this equation where we have like an a times b plus a times c, where in our case our a would be the x minus 6, which shows up with here and here, and then our b would be like the x squared, and our c would be like the negative 1. And so we're going to go from this part to the left part, or the left side here. So then we're going to go down to, this is going to become a x squared minus 1 times x minus 6. Where again, this would be like our a, and then this is like our b and c here. Okay, so, and then we'll write out the denominator again, x plus 2, x minus 2. Okay, and we can factor this a little bit further here because notice we have, again, a difference of two squares right here. So let's write this as x plus 1, x minus 1, x minus 6 over x plus 2, x minus 2. Okay, and now let's stop here for a moment and see if anything can cancel out. It looks like nothing will, so that's going to mean that we have no holes for this function. And that is going to wrap up step 1. So now we want to move on to step 2 and identify the x and y intercepts. Now the x-intercepts are going to occur when y equals 0. And so looking at, let's see, the original function here, or actually let's look at the factored form right here. And y will equal 0, or f of x will equal 0 when our numerator is equal to 0. And so in order for that to be equal to 0, we need any one of these these factors here to be 0. And so if we have an x value of, say, negative 1, 1, or 6, we will get the numerator to be 0. So our x-intercepts are going to occur at, let's see, x equal negative 1, 1, 6. Okay, and so that wraps up with the x-intercepts. Now let's find the y-intercepts. And let's see here. The y-intercepts are going to occur when x equals 0. And this is where I think looking at the original function is a little easier. So if we look here, we plug in 0 for x, all of these terms are going to go away. We're going to be left with a 6 in the numerator. And then in the denominator, this term right here, the x squared, is going to go away. We'll be left with a -4. So this will be 6 over -4, which simplifies to a -3 over 2. So it's going to be y equals -3 over 2. And let's see here. I think that's going to wrap up with step number 2. And so we can move on to step number 3, identifying the asymptotes. All right, so identifying the asymptotes, let's look. Let's start with the vertical asymptotes first. And the vertical asymptotes are going to occur when our denominator is equal to 0, because then we would be dividing by 0, which we cannot do, that is undefined. And that's going to occur when x equals -2 or x equals 2. So we're going to have vertical asymptotes at x equal -2 and 2. And let's see, horizontal asymptotes. Looking at the original function here, we can notice that the degree of the numerator is a degree 3, and the degree of the denominator is degree 2. And in that case, when the degree of our numerator is greater than the degree of the denominator, we're actually not going to have any horizontal asymptotes. So I'm going to write this here, asymptotes, none. Okay, but one thing we got to be careful with here is we got to look at slant asymptotes. And the slant asymptote will occur when the degree of our numerator is exactly one more than the degree of our denominator, which does occur in this case. And so we're going to have to go ahead and find out that slant asymptote. And in order to do that, we're actually going to want to perform long division here. So what we want to do is we want to divide the numerator by the divisor and find the quotient that comes out. So I'm going to go down here. Let's see. I think the numerator was x third minus 6x squared minus x plus 6. And we're dividing that by the denominator x squared minus 4. Okay, and so doing this, let's see here. What we want to do is we want to look at these leading terms here and see what we need to multiply x squared by to get x cubed. And in this case, we need to multiply it by an x. So write an x here. And then we're gonna multiply this x back through by this and write that right here and subtract. So x times x squared, x cubed, that's what we wanted. And then x times -4 is going to be a -4x. But we want to be careful and write that under the other x term here raised to the first degree. So we keep everything lined up, and we'll fill in a placeholder here with a 0. I'm going to go ahead and subtract these. Those cancel out. The -6x squared is going to drop down. And then -x minus 4x is going to be -x plus 5x, which will be -x plus 4x, which will be a positive 3x. And now we're going to want to repeat the process here, multiplying or seeing what we can multiply x squared by to get -6x squared. Oh, sorry. Actually, and we want to drop this 6 down here in this step. Okay, and so back to what I was saying, where we want to multiply this x squared by something to get negative 6x squared, which in this case is going to be a negative 6. And so that, multiplying this back through, we're going to get negative 6x squared. Negative 6 times negative 4 will be a positive 24. So we can go ahead and write that here. And again, fill in a placeholder right here. Subtracting those, these are going to cancel. We'll be left with a 3x on bottom. And 6 minus 24 will leave us with a negative 18. And now we can notice here that there's nothing we can multiply the x squared by to get a 3x. So this right here is actually going to be our remainder. And this x minus 6 will be our quotient. And so I'm going to write over here that in general, when we have long division, we have something in the form f of x over the divisor dx equals qx, our quotient, plus rx over the divisor dx, where rx is our remainder. And so this part right here, the quotient, that is going to be our slant asymptote. So in our situation here, our slant asymptote is this part right here, because if we wrote it out, we would have the quotient is x minus 6, and the remainder here would be 3x minus 18. And so let's see here. If I were to write this out, I would say f of x over dx. I'm not going to write out the full polynomial there, but I'm just going to say it like so, equals x minus 6 plus our remainder here, 3x minus 18 over x squared minus 4. Now the reason that we get a slant asymptote here is because we can think of this right here as a, well, this first part is in the form of mx plus b for the equation of a line, and then the slope intercept form. And then the second part here is some rational function, right? 3x minus 18 over x squared minus 4, where we can notice that as x increases, the denominator here will be growing much faster than the numerator due to the x squared in the denominator, which is going to result in this term right here ultimately going to 0 as x gets larger, which means that we're just really going to be left with this part right here, the x minus 6, which tells us how our function that we're starting with there, the rational function, is going to behave as x gets larger and larger. And that is why we see a slant asymptote at this quotient right here, the x minus 6. Okay, so I think that wraps up with, and I'll just write the slant asymptote right here. That's going to be at y equals x minus 6. Okay, so I think that wraps up with step number 3. And so now what we need to do is we need to create a sign chart. Let's see, I'll go ahead and do that right here. So draw out our little number line, and we want on this number line to put all of our x-intercepts and our vertical asymptotes where they occur. And so it's here, x-intercepts negative 1, 1, and 6. So maybe I'll say negative 1, 1, and I'll put 6 like somewhere over here. And our vertical asymptotes occur at negative 2 and 2. So let's say negative 2 and 2 right here. And now what we want to do is we want to find out whether the function is positive or negative in each one of these intervals here. So I'm going to go ahead and just do the first one, and then after that I'm going to fill in the chart because I've actually already done this and I know what this chart's going to look like, but if you want, you can go through and verify and see for yourself that each one of these what I'm going to have here is correct. But I'll go ahead and do the first one here. So we can plug in a negative 3. If we plug in a negative 3 over here, this is going to be negative 3 plus 1, which is going to give us a negative, something that's negative. And a negative 3 minus 1, again, we're going to have something that's negative. Negative 3 minus 6, negative. So our numerator is going to turn out to be a negative. And then in the denominator here, we have negative 3 plus 2, which is going to be negative, and a negative 3 minus 2, which is also going to be negative. So our denominator will be positive. So we'll have a negative over a positive, resulting in a negative. And then I'm going to go ahead and fill in the rest of this here rather than go through each one. It's going to turn out to be like so. All right, so we've completed step number 4, and now all we need to do is graph. And so I'm going to go ahead and see here. I'm going to graph right over here. Let's see if I can fit this in here. All right, I'm going to draw, let's see, 6. I'll draw 6 about so. Negative 6 will be about right here. So 6, 6 right here, negative 6. And I'm drawing this negative 6 here because I know from the slant asymptote I'm going to have that y-intercept of negative 6. And then this 6 is one of the x-intercepts. We also have an x-intercept at 1, negative 1, and then we have the vertical asymptotes at negative 2 and 2. And I'm going to begin by drawing in that line. Oh, and we want to draw our y-intercept at negative 3 over 2, which might be somewhere around here. Okay, so I'm going to begin by drawing in these asymptote lines. So the slant asymptote, which is y equals x minus 6, has that y-intercept at negative 6 and a slope of 1. So that's going to end up looking something like so. And then we have our vertical asymptotes at negative 2 and 2. So that will be something like this. And let's see here. So we have all of our vertical asymptotes, slant asymptotes, no horizontal asymptotes. And now using our sign chart here, we can begin filling in some of this graph. So let's see here. We know that between, let's say, negative 1 and 1, we're going to be negative, and then from 1 to 2, we're positive, and negative 1 to 2, or negative 1 and negative 2, we're positive, and we're crossing this, we have a y-intercept right here, and so that means that this is going to look something like so let's see, something, we're going to cross through negative 1, hit that y-intercept, then the x-intercept at 1, and come back up and ride right along these asymptotes here. Okay, so that fills in the gap from negative 2, negative 1, 1 to 2. Now let's see here, from 2 to 6 we're negative. So from 2 to 6 we're negative. That means we need to be riding right along this asymptote here, and then coming up and following along this asymptote here, and then it's actually going to come right at the x-intercept here and just ride right along this slant asymptote, the y equals x minus 6 line. And then down here. And then let's see, so that fills in that part. And yep, whenever we passed 6, we went positive at the x-intercept. And let's see, to the left of negative 2, we are negative. So we're going to be down here like so. Kind of extend this out. extend this so we're negative. So we're going to be writing right along this asymptote and this one like so, and kind of just following along that line. And that right there is going to be our final graph. Awesome. And let's see, I'd like to end today's video with a little fun fact from philosophy. Did you know that the term cosmos, which we may in today's terms associate with the word universe, the ancient Greek philosophers, when they used this term, they were really referring to something that was unified and ordered and had a structure that could be described through what they would call logos, which is a sort of a rationality or a rational explanation. And so, in general, whenever they talked of the cosmos, they were talking of this unified and ordered structure that could be described through reason and rationality. And we kind of see this idea reflected in today's word cosmology, which combines the words cosmos and logos.